Okay, today we're talking about solving inequalities. Guys, I still remember the greater than and less than by the alligator mouth. Whichever side the inequality is opening towards or eating is the larger side. So you would say whatever's on the left side is, see which way the inequality is going, greater than or less than whatever's on the right side. So here an inequality compares two expressions. An equal sign compares two expressions as well. It compares them to tell us that they're equal. An inequality tells us that one side is bigger or smaller than the other. Solving inequalities is just like solving equations with one exception. When you multiply or divide by a negative, you must flip the inequality sign. So here I would do a two-step add or subtract, minus 6 on both sides, and I get 6 is greater than negative 2x. And then divide by the negative 2. So here, since we're dividing by a negative, that sign has to flip. Okay, so now instead of reading greater than, it reads less than. So negative 3 is less than x. So that means that any values that are less than negative 3 will... sorry, I messed up. So now when I read this, I always want to read my variable first. So even though x is on the right, I'm still going to say x is greater than negative 3. So any values bigger than negative 3 are going to work. The way it's written, it's negative 3 is less than x. So that means that, in contrast, anything that's going to be a solution, anything that's going to be x, has to be bigger than negative 3. When we graph inequalities, we use a open circle, so it's not shaded, for the less than and greater than. And we use a shaded circle, so it's colored in, for less than or equal to and greater than or equal to. That just means that that point where the dot is included for the or equal to and not included for the other ones. Okay, and then you have to shade all possible solutions. So I guess I can just do this one again real quick. Oh, actually, this one is different. The 2 is positive. So we don't need to flip the sign because that 2 is positive. I divided by a positive value. So here it says 3 is greater than x. That means x is smaller than 3. So I always like to read it with the variable first. So it would be x is less than 3. So when we graph this, we have a number line. And 3 is our, I guess, focus point. And it's going to be an open circle. Okay? Because 3 is not included because it's not equal to, and x is less than. Less than means to the left, greater than means to the right. So I'm going to shade everything to the left. Alright, let's look at some more examples to try to bring that understanding home. So here I want to solve for n, so we're going to move that 5 over, and I get 10n is less than. All we're doing is subtracting 5, so negative 50. And then divide by a positive 10. Since I'm dividing by a positive 10, there's no reason to flip the sign. So I get n is less than negative 5. Always read it with the variable first, whether it's written on the left or the right. So n is less than means left, and it's going to be an open circle. Oh, this one has a little bit more going on, so I need to simplify that left side. So distribute the 4. So I get 12x minus 20 plus 7. It's greater than or equal to 8x plus 3. So the minus 20 and the plus 7 can be put together to give me 12x minus 13 is greater than or equal to 8x plus 3. So now I want to get the variable on one side. Move the 8x over. 4x minus 13 is greater than or equal to 3. Alright, so move the 13 over and divide by 4. So since I'm dividing by a positive, there's no reason to change it. So I get x is greater than or equal to 4. Always read it with the variable first. So that's going to be a closed circle because of the or equal to part. Wow, that looks like a mess, but closed circle, and greater than is to the right. So I would shade everything to the right. A couple for you guys to try. Give it a go, and then we'll go over it in class for sure. All right, compound inequalities. I think should be new for you guys. Some of you might have seen it before, but it's kind of a new concept. All it is taking the inequality sign and putting two of them within the same problem. So a compound inequality is two inequalities joined together by the words and or. So and you won't always see, you'll always see or. So in this first example, 3 is less than x is less than 7. That means that 3 is less than x and x is less than 7. So x has to be more than 3 and less than 7. It falls somewhere in that range. So if I wanted to graph this, I would have a number line. I would have 3, I would have 7. They both have open circles because there's no or equal to. And x is in the middle there. Okay, more than 3 and less than 7. And then with the ors, it means it can satisfy either one. It doesn't have to be both. So x is greater than 2. So if I found 2 on my number line, x is greater than would go to the right. Or x is less than -1. So I need to find -1 on my number line and say x is less than that. So for or, it's going to be either or. For and, it has to work for both. And this slide kind of hammers that home. A compound inequality containing and is only true if both inequalities are true. This is called the intersection of the two graphs. The intersection looks like this. A compound inequality containing or is true if at least one of the inequalities is true. So this one doesn't have to be both, it has to be one or the other. And this is called the union. So the union looks like this. Alright, so I just have a couple examples we'll do. -2 is less than or equal to x minus 3 is less than 4. So this is an and inequality because I don't see the word or. So it must be an and inequality. I am not going to try to do it all together. I'm going to take the left side in the middle. So -2 is less than or equal to x minus 3. And I'm going to take the middle and the right. X minus 3 also has to be less than 4. So that's it. That's the new step right there. Split it up. Now you have an inequality that you need to solve. Two inequalities that you need to solve. So add 3. I get 1 is less than or equal to x. Here I'm going to add 3. I get x is less than 7. So this means I always agree with the variable first. X is greater than or equal to 1 and x is less than 7. So greater than or equal to 1 will be a closed circle going that way. Less than 7 will be an open circle going left. So anywhere in that middle area is going to satisfy the values for x. Second one over here has the word or. So that means only one of them needs to be true. So x is less than 9. Yay, that's easy. Okay, so then 2 plus 4x is less than 10. Let's move that 2 over. 4x is less than 8, and then divide by a positive 4. No reason to flip anything. X is less than 2. So I have two inequalities. X is less than or equal to 9. X is less than 2. So on a number line, I would need to find 9. Less than or equal to is a closed circle, and it goes left. So any of those numbers will work for the x is less than or equal to 9. And then 2 is also going to go left. So it's kind of redundant. You don't even need to put it because if it's less than 2, it is also less than 9. And then after this, I believe we just have some problems for you to try. Give them a go, and then we will go over them in class. It'll be good for you to already have them done so you can kind of see if you made a mistake. But if you want to wait until class and try it, that's A-okay too.